Hey guys, welcome back. In this Blender video, we're going to model the 2026 FIFA World Cup Adidas Trionda ball. We'll see how to create the wavy panel pattern and build the whole ball from scratch. We'll also look at the math behind the design and see how those patterns are arranged around the sphere. Along the way, we'll go through different modeling techniques and use different modifiers to speed up the workflow. We'll keep the geometry and topology nice and clean, and we'll end up with both a nice low poly version and a smooth high poly version. So now, without wasting any more time, let's jump right in. First, let's take a look at how this ball is actually designed. The whole structure of the ball is designed in such a way that it is made up of 4 triangles, which is called a tetrahedron. If you look at this 4-sided triangular shape, you'll notice that the wavy panel pattern is basically the same on every side. The math behind the ball works by taking that exact pattern from the 4 sides and projecting it onto a sphere. That's how those flat triangular shapes wrap around and turn into a perfectly round ball. So now, let's start modeling it. First, let's add a sphere. For this, I'll use a rounded cube, which gives us a sphere shape with clean geometry. You can enable the Extra Mesh Objects add-on in the preferences if you want to add that. Now I'll add the reference image of the pattern here. Move it to the center of the sphere to align it properly. Here on the side, turn down the opacity of the image so we can see through it properly. Then align it so it matches correctly with the sphere. After that, let's add a single vertex mesh here. Now just start extruding, following the pattern lines like this. Here we'll delete this part. We'll keep it only up to here because the matching point of the pattern from the other side is somewhere around here. Now we have to project this pattern line curve onto the sphere mesh. First, let's move this curve forward out in front here. Then let's add a shrink wrap modifier. With the eyedropper, select the sphere mesh to project onto. Over here, select project. And here, select the y-axis because that's the direction we want to project. And now that will project perfectly onto the sphere. Now we have to create duplicate copies of this pattern all around the sphere, using the correct angles and all the required math. First, I'll show how to do it manually and explain why. Then we'll look at the quicker method to do that. First, let's change the pivot point to the 3D cursor so we can rotate everything from the center point of the sphere mesh where the 3D cursor is. Now we need to duplicate this line and rotate it. But how do we know the exact angle so it rotates precisely? All right, let's look at this triangle face. You can see 3 lines coming right out from the center, same as the pattern. And as you can see here, the exact angle between them is 120 degrees, which is shown when I calculated it with the Measure It tool. So that's the same thing we need to do here for this pattern. Rotate this copy by 120 degrees. Then duplicate it again and rotate another 120 degrees. And that gives us the pattern perfectly. Now we need to duplicate this onto the other sides all around. So how do we know the exact angle for that? Let's look at this tetrahedron. The front pattern is exactly on the same side as this front triangle face. So this front face has to be duplicated and moved to the bottom. That's how it is. So we need to know the exact angle so it rotates perfectly. Now here you can see the angle from the center point of the tetrahedron to side 2 point. When I calculated it, the angle shows 109.47 degrees. So that's the exact angle we need to rotate this. Now here, this front triangle face will first rotate 180 degrees to flip it because the bottom side is facing the opposite way, as you can see. Then from the center point, rotate it by 109 degrees from the 3D cursor. And that's how it is rotated perfectly there. Now to duplicate this on the other 2 sides, it's the same 120 degree angle. If we look from the front, it's the same 120 degree angle how we rotated the front pattern lines. So from the bottom side, rotate it 120 degrees from the center on one side, and that does it perfectly. Then again, duplicate the bottom and rotate it again, this time by negative 120 degrees to place it on the other side. And that's how we do that. So in the same way, we have to rotate the pattern on the sphere. So here, let's do the same thing as we did on the tetrahedron. First, duplicate a copy, then rotate it 180 degrees to flip it, and then rotate it onto the bottom side using 109 degrees from the center. Then duplicate copies on the other sides using the 120 degree angle. Now, with this manual method, we have to do a lot of work. We have to rotate everything, then merge the vertices, and we'll have to repeat those same steps again later. So it can take quite a bit of time. Instead, we'll use a slightly quicker method, and that is geometry nodes. So let's see how we can do that. First, let's split the view and change this tab to the Geometry Nodes editor. Then, for this curved pattern, let's create a new geometry node setup. Now, first add a join geometry node and plug it in here so we can combine and connect everything together. Now to create the other two arms, we'll add a transform geometry node. With this, we can rotate, move, and scale our geometry. So here, we want to rotate this curve by 120 degrees. Make sure to connect the main group input directly to the join geometry node as well, so our original curve stays right where it is. Next, type 120 into the y-axis field to rotate the curve in that direction. Then, duplicate this transform geometry node, connect it here, and plug it into the join geometry node. Just like that, we've created our third arm by rotating it another 120 degrees. And now the front pattern is done. Now we need to duplicate this complete front pattern onto the other sides of the sphere. So our first join geometry node only contains these first three arms. To duplicate that entire front pattern around the sphere and connect everything together, we need another join geometry node. So duplicate the join geometry node and plug it in here. Then duplicate the transform geometry node. For our front pattern to stay where it is, keep the first join geometry plugged into the other. Next, connect the output from the first join geometry node into the new transform geometry node and plug its output in here. This lets us rotate the entire front pattern. Here, first rotate it 180 degrees on the y-axis to flip it, and then rotate it 109 degrees on the x-axis. Type the full value, 109.47122, to be completely precise so there are no gaps. As you can see, that's the full value shown here. Now make it negative so it flips to the bottom. That's exactly what we want. Next, duplicate this transform geometry node. We want to copy this piece onto the sides. So connect the wire here. For this one, rotate it by 120 degrees, then plug its output in here. Then duplicate this node. Again, connect the wire here and plug the output in here. This time, rotate it by negative 120 degrees. And now we have our pattern perfectly here. Now we want to merge these patterns together. To do that, we'll move these vertices so they line up and merge nicely. Now to merge this, actually we can add a merge by distance node which will merge nearby and overlapping vertices. Adjust the value until everything merges together perfectly. The meeting point is this vertex right here. We have an extra vertex here, so let's delete it, and this is fine here. We can also adjust these vertices slightly to make the shape look nicer. Now let's apply the shrink wrap modifier so the mesh snaps perfectly onto the sphere. After that, add the shrink wrap modifier back again. Use the eyedropper to select the sphere mesh as the target. This time, keep it set to nearest surface point because now we just want to wrap it around the sphere while keeping it smooth. Now select this entire curve and use Loop Tools Space to evenly space the vertices. Then use Loop Tools Relax to smooth everything out, and that looks good right there. Now that our pattern layout is completely finished, we need to fill this area with clean topology. Before we do that, we need to apply our modifiers so we can edit the actual mesh. First, let's create a duplicate of our modifier setup. We need this backup because we'll reapply it later to copy our filled pattern onto all the other sides. This way, we don't have to repeat the same filling steps 4 times. For now, disable the modifiers on the backup copy, then apply the modifiers on the main one. Now that we have this, first, let's use merge by distance, just in case there are any floating vertices. Now we want to fill this area. Select the edges of one section of this pattern that we want to fill. We only want to fill up to the middle where the next section will meet. So let's activate the geometry nodes modifier and see where the other section meets. The meeting point is right over here, so we'll only fill up to this point. Next, we need to build the geometry here with clean topology by connecting the edges. First, let's mark the border edges as a seam. This way, we can quickly select this section again later. Then inset this inward to protect the boundary structure. Now let's fix the geometry here. First, turn on Auto Merge here at the top. Also, change the snapping mode to Vertex. Now select these vertices, move them, and snap them together here. Over here, directly select these vertices and merge them at the center. We'll merge until this point. This corner needs to stay sharp, so let's connect these vertices here. Then dissolve this edge. Now this part will remain sharp. Now, with the knife tool, add a cut over here in the middle, then dissolve these edges. Now we want to fill this middle area. To do that quickly, first delete this face, then select this entire edge loop. Then go over here and choose Grid Fill. This will fill the area cleanly and quickly. Here, in the corner panel, we can tweak how we want to align the edges. So we'll set it like this, and that looks good here. Remove this unnecessary seam in the middle. We don't need that. Now, press Ctrl L to select the section where we added the geometry, and we'll delete the rest of the sides to duplicate copies of this section all around. Over here, choose Seam to select only this section. Okay, after choosing Seam, it still selects the full mesh. So choose Normals, which works here. Seam doesn't work because the rest of the parts aren't filled yet. Then press Ctrl I to invert the selection, and then delete the rest of the edges. Next, duplicate these modifiers again so we have another backup for later. Then apply the original modifiers. Now we need to fill this area. Select these vertices and merge them at the center. Then press Alt-S and move them out slightly. Now, when we press Ctrl L and choose Seam, it correctly selects only this section. Then delete the rest of the sections. Now we can tweak this section and the other copies will update automatically. Let's remove the seam of these edges. Now we can adjust these vertices by sliding them to space them more evenly. Take your time here and space them nicely so everything looks clean and even. Alright, after spacing the vertices, this looks good. Next, we need to add the cuts on the ball. So for that, we'll have to apply the modifiers. Before we apply it, let's keep a backup copy of this mesh just in case we mess it up later. Now add a subdivision surface modifier. Okay, that looks good. Now let's apply the modifiers. Okay, so to make this a perfect sphere, we can go over here and use ToSphere, or we can press Shift-Alt-S and drag the mouse. Then here in this corner panel, drag this all the way up to make it completely round. Now, to add the cuts. Select one of the seam edges, press Shift-G, and choose Seam to quickly select all the seam edges. Then bevel them. After that, press Alt-E and choose Extrude along normals. Extrude them in just a little to create those cuts. And just like that, we've added them nicely. If you want, you can also bevel these edges to keep them a little sharper. If, in case there are slight artifacts on the mesh because it's low resolution, what we can do is add a shrink wrap modifier. Add it after the subdivision surface modifier. Then, with the eyedropper, select the sphere as the target. For the target sphere, enable Shade Smooth. Then also add a subdivision surface modifier to smooth it even more. Now for our main ball mesh, let's apply the one-level subdivision surface modifier, and then also apply the shrink wrap modifier. After that, add a subdivision surface modifier again. Now this is subdivided by one level, and it will be nice and smooth. So now here, add the cutouts by beveling, then extrude inwards the same way. And now that looks nice and smooth. Great. Alright, so that's it for this one. Hope you learned something useful from this modeling practice, and hopefully you picked up a few useful modeling techniques along the way. If you found this video helpful, don't forget to like, share, and subscribe. Also, comment below and let me know your feedback. Thanks for watching, and I'll see you in the next one.